Hi everybody. Today we start chapter 14 with this lesson. It deals with mixtures and solutions. So it's fairly math heavy, and we also take time to look at table G and then a little bit of conceptual material. So the properties of solutions. A solution is a homogeneous mixture, which we also know as an aqueous solution. And remember, aqueous solutions have the symbol AQ after the formula. We have two definitions right now. The solute is the dissolved particle. The solvent is what dissolves the particle. So when sodium chloride, salt, dissolves in water, the sodium chloride is the solute and the water is the solvent. But be careful. If they just give you NaClAq and they ask, what is the solvent? You have to realize it's the water. Particles do not settle out of a solution and they cannot be separated by filtration. So if you put a solution through a coffee filter, nothing will end up on the filter. The substances that dissolve most readily in water are ionic compounds, which you know are metals and nonmetals bonded together, and polar covalent molecules, which you know are asymmetrical molecules. Nonpolar molecules do not dissolve in water. So if two liquids dissolve in each other, they are considered to be miscible. If two liquids do not dissolve in each other, in other words, they are insoluble in each other, they are immiscible. But just remember the adage, like dissolves like. So polar molecules dissolve in polar molecules. Nonpolar molecules dissolve in nonpolar molecules. And if you have charges, you will dissolve. So polar molecules will dissolve ionic compounds. There are three types of solutions. A gaseous solution is when two gases are mixed together, like air. The third one is a solid solution, where two solids, two melted metals, are mixed together. These are alloys. Some alloys we know are brass and bronze. And the third type is a little trickier because it has three parts. It's considered a liquid solution, but there is a liquid solvent with a solid, liquid, or gas solute. So if we have a gas solute in a liquid solution, it's something like carbon dioxide of soda dissolved in water. Kool-Aid is an example of a solid solute dissolved in water. And antifreeze, which is a liquid dissolved in water, would be an example of a liquid solute in a liquid solution. The concentration of a solution is a measure of the amount of solute that is dissolved in a given quantity of solvent. If we did this qualitatively without any measurements, you probably know the word dilute, which means there's only a low concentration of solute, and concentrated. in which case there is a high concentration of solute. But these solutions are not reproducible. If I asked you to make a dilute solution of Kool-Aid, there are endless possibilities for what you could come up with. And dilute to you may be concentrated, taste-wise, to somebody else. So instead, we have a quantitative way of measuring out a solution. And this is where the math of the course comes in, of this chapter. The most important one we're going to probably look at is molarity. It has the symbol capital M, and it's the number of moles of solute dissolved per liter of solution. And when we do the problems, we'll see how we work this out. The second type, most common type, is percent by mass. Percent by mass has the formula grams of solute over grams of solution. The grams of solution is the combination of the solute and the solvent. And sometimes those problems are a little trickier, which we'll look at. The reference table gives the equation as percent by mass equals mass of part over mass of whole times 100. So hopefully you can see that's essentially saying the same thing. Percent by volume, we don't really use too much. I might give you one problem in homework that deals with it. And the next most common type question asked is parts per million. Parts per million on the back of the reference table looks exactly like percent by mass, except instead of multiplying by 100, we are multiplying by 1,000,000. And this is used when you have very, very small concentrations. So that's essentially it for the types of formulas. Let's do one or two problems here, and then we will call it a night or day. So worksheet on molarity, it says use ESA. What's the molarity of a solution? Number one, that has 4 moles of solute in 2.0 liters of solution. This is the easiest kind of problem we can get. So if I look on the back of my reference table, I have my formula for molarity. Molarity equals moles of solute over liter of solution. And I'm just going to abbreviate solution this way. We're solving for molarity equals 4.0 moles over 2.0 liters. Molarity has the symbol capital M. 4 divided by 2 is 2. So 2.0 moles per liter. If only every problem was this easy. So the hardest problem they can ask you is question 3. So I'm going to do 3, and then we're going to call it. This will be the last one. How many moles of H2SO4 are needed to prepare 5 liters of a 2-molar solution? H2SO4 aqueous is sulfuric acid. Molarity equals, we can shorten it down, moles per liter. This time, they give us 2.0 as the molarity. We're solving for moles, and there are 5.0 liters. So X, multiply both sides by 5, is 10, and then 2 sig figs, I'll put a decimal here. Now there are going to be questions where you have to solve for mass, like number 4. But that's the ones we're going to work on in class. So that's it for tonight, or for whenever you're watching this. And have a great night, and we shall see you in class.